next presentation from our foreign colleague, Bora Ju. She is an instructor in Harvard College. She's going to tell us about methodology and techniques of identification of losses and damage with the use of artificial intelligence, using the city of Mariupol as an example.
Hello, thank you very much for inviting, and I apologize for this time, my mistake, for this time difference recognition that was a little bit delayed from my from my end. So I would like to share with you my presentation today is about identifying special changes in Mariupol city using supervised learning and open data. Just try to. All right, so basically, just to give you a brief background about open data, why is it important? As you can see there, there are a lot of open data is becoming crucially important, especially for geospatial information and analytics. As you can see on the screen, there are a lot of open source software, processing data softwares, but also a lot of data available at the international level, but also at the local level. Recently, also Google has launched this Earth Engine catalog where you can access a lot of open data, including surface reflectance data or other risk data such as flooding. It's becoming crucially important because you can do a lot of analytics, including big data analytics and other sources and fit-to-purpose analysis with very low cost. But at the same time, it is true that open data softwares and data are have limitations such as low resolutions. But it is providing a lot of great opportunities for different types of analysis. So for this analytics, I have used supervised learning. So basically, for machine learning and artificial intelligence is a broader concept of machine learning. Machine learning has basically some embedded algorithm within it. And we can divide it into two big streams. You can see that there is a supervised learning and unsupervised learning, but there are other types of machine learning algorithm, including hybrid method. But I'll give you a brief introduction of what is a supervised learning and an unsupervised learning. So basically, like you can see in the screen, supervised learning, you have to provide certain types of trained data sets, while unsupervised learning doesn't need this kinds of trained data set, or we'll call it maybe data sampling. So it will, for unsupervised learning, it will provide the algorithm itself will try to detect the different kinds of data from the input raw data, while for the supervised learning, you will need to identify the type of data from the input raw data. So for this type of analysis, I have used supervised data, supervised algorithm. So meaning that I have identified the samples so that the embedded algorithm can detect or identify the different types of data sets that I wish the algorithm to predict from to the output data. So why have I chosen Mariupol city? Well, from my background research, I have detected that Mariupol city is one of the mostly affected city with 90% of damaged area. So so from that background research, I have decided to see what are some of the special changes, including areas that have been affected by war, dividing by pre-war stage and post-war stage. So, so based on those two periods, I have downloaded or I have searched from the linked data provided by Google Earth Engine, the reflectance data, and have divided into several land use categories, including urban, industrial, and underdeveloped area. The second category was green forestry area. Third category was agricultural lands. Fourth, zones affected by war. And fifth category was water banks and water rivers, water-related land uses. So I have also used, after classifying those land uses into different categories, then I have used this embedded algorithm, which is ee.classifier.smartcard.train, which is a supervised learning algorithm embedded within Google Earth Engine platform. And this uses JavaScript. And I have used the post-war surface reflectance data to identify some of the war-affected regions, and so that the supervised learning algorithm can predict the war-affected region. So that required some cross-validation. So meaning that there are two types of analytics conducted, one for prediction of the output, and another also I have identified the war-affected regions so that it can sort of compare the results obtained from the first analytics to see whether it matches with the second analytics. So the accuracy rate was 88.2% for the first analytics conducted. So I have actually conducted several analytics. Like majorly it was 3 analytics. The first two to predict, the last one to conduct an accuracy rate. And so this algorithm shows, this framework, sorry, shows the overall flow of training the data set and then using this embedded algorithm and doing cross-validation and importing that into ArcGIS Pro, and also doing a focal statistics, meaning that I have used the raster data to predict war-affected regions, and focal statistics permits to decrease the noise level, and it helps to sort of aggregate data that have the majority within certain aggregator region. So just to let you know about, so these are the examples of trained data sets. So I literally drew 30, 40-ish of war-affected infrastructure area. And mostly it was large-scale infrastructure regions because of this low type of resolution of open data, which is also one of the limitations of open data. But I've used this trained data sets. And then the algorithm used for this supervised learning was classification and regression tree cart. It actually uses a 50% likelihood method. So meaning that, as I've told you previously, there are several land use categorization, including urban, agricultural, green areas, zones affected by war and water. So based on my trained data set, the algorithm defines whether the regions are war affected regions or water area, is a green area. So based on that algorithm, it tries to identify the categorization of each land use, or per se like pixel-based raster data. Is it war-affected region or agricultural lands, green area, or urban area? So I'll just share with you this living map. I don't know if you can see. Yeah, so these are some of the results of supervised learning embedded algorithm outputs. So this is one of the trained data sets. So this is pre-war and this is post-war. So I've used post-war surface reflectance data to extract some of its sample data. And this is also one of the other sample data training used to detect war affected regions. And this is, it appears as a high resolution because this is one of the results obtained from the supervised learning. And I've tried to identify from the obtained raster data. I've zoomed into one of the areas identified by the output data. And I searched from Google Earth Engine Pro, which uses high resolution Maxar platform-based surface reflectance data. So it has higher resolution, so it appears as a higher resolution, but this is not from Google Earth Engine catalog. So you can see that the raster data location well identified war affected region. And this is also an output from raster data extracted from that previous supervised learning analysis. So let me go back to my PowerPoint. So as you can see, I've only selected Mariupol city to do the training for supervised learning and identify war-affected region as an output of raster data. But there is a potential for scaling up at the national level. But this will require to dig into using unsupervised learning because if you keep using supervised learning, you will have to identify war-affected region every time manually. So if we can embed unsupervised learning algorithm and embed that into and use the Google Earth Engine catalog provided data and just link it with ArcGIS Pro and just having an algorithm that can directly make use of this linked API data, then I believe that within 1 month interval, it will be easy to identify all war-affected regions and update it into this Google Earth ArcGIS Pro software, and then we could save this output data into a locally saved
Dear
data
Bora,
geodatabase, and either share it into an open portal or non-open portal. So there is a way of digging into this unsupervised learning and having this automated analytics conducted at the national level. So my conclusion is that Google Earth Engine is a great source of identifying spatial changes, including war-affected regions in a very with a very low cost fee. But it also has limitations, including low quality data provision and also the need for validate the analytics conducted. But at the same time, it can provide a lot of opportunities, such as if we can use unsupervised learning it can provide a lot of opportunities of updating those war affected region analytics on a monthly or 2-week basis. So so my presentation will stop here. Thank you for listening.